Okay. And this is the paper you're talking about?
Yes, sir.
Okay. So we are doing this thing together because I want you to participate in it.
Yes. So I already did the paper. So I just
You
want
already done
to
the paper.
yes, sir. I did it today. So I'm just revising the questions that I do not understand.
Okay, okay. Which number? Which number?
Yes, sir. Number one, I don't understand. Let's start with number one. Because I wrote my answers D.
Number one.
Yes.
Okay. This number one. What could be? Okay. What could not be a measurement of physical quantity? What's a physical? A physical. That's called a physical quantity. So first of all, know this one first. That is, first of all, know this one. That's called a physical quantity.
Yes, sir.
Okay, fine. So it must be it's a quantity, not a unit. If you look, let's first of all see this. Okay. Looking at this is a K Kelvin. It's coming from temperature. It's
Yes,
a
sir.
unit. Okay.
Yes.
And it must also have a magnitude and a unit. Coming this particular one, unit of what? So this one unit of what?
Uh
That will be unit of what?
it's for force.
A force, Joule. You
Yes.
have Joule, Joule per Newton, then per meter. Joule means kilogram meter square per second square. That's energy as Joule. Then divided by Newton is kilogram meter per second square. That's force mass. Then another if you do that, so what happens?
The kgs cancel out, and then
What
yeah,
happens?
you're left with
Confirm. We are
yeah.
going to get one. Confirm that whether it's wrong, whether I'm true or not.
Yes, yeah, correct. Because the kgs cancel out, and then you're left with only S minus two.
So look at it now.
They
Which
both
one is not? It's not a physical. A physical quantity must have an unit. It must have magnitude and unit. If you look at it
yes,
now, unit is Kelvin. That's from temperature. Temperature is a physics, is a quantity. Now this one I
yeah.
have no ask a quantity one, but there's no unit. So we cannot even know, okay, which instrument are you going to use to measure it? Nobody knows because it's not a quantity. It's only a
Wait,
quantity must have.
can you explain why you
Now,
said kg meter squared over? Use that formula for energy over that.
this is meaning of this now from this one, from here, from this. This one mean per
Yes,
Newton, this one mean per this one mean Joule.
yes,
Joule.
yes,
That would be Joule. That's meaning of per meter.
yes.
Do the mathematics. When this one goes or what happens? It become minus.
Oh, the Jew represents energy. That's why you wrote that formula for energy, and then
Yes. And
meters is for
this is
period.
this is
That's what I
Joule.
want to understand.
You understand now?
Yes, Jew.
Okay. Two, So this is possible. So this is a quantity. This one is not a quantity. This is going to be the answer. If you look at this one too, Pascal. Pascal is unit of what?
Pressure.
So it's unit of pressure. That's not Pascal. And if you have to do when you do the units, are you going to get something meaningful? So that was that look at. So this one now is Pascal, which is pressure, and unit of pressure means kilogram force over area. That's a kilogram. That is force over area. This one is kilogram per second. Yes, that's force. Mass times acceleration. Fine. This is a meter. So Fenja is going to give you -1. That's a press. Pressure will give you the kilogram per meter per second square. Now, then times meter square over n. N is the Newton, which is kilogram meter per second square. If you do, you are going to get a unit. Because if you do it now, this and this will give you 2. This and this will cancel. This and this will cancel. So this and this will give you m power 2 over m. That will give you m, which is correct. It's having a unit and it's having a quantity. So this one is the same as 17 meter, which is a length. So this one is the direct Tesla. This one is what direct. So this will be terameter. So these, they are quantity. Only D, which is not quantity, and is the correct answer. So do you get it now?
Because you got 1.
Because there's no unit. Unit cancel. So the most number, a physical quantity must have a magnitude together with unit. There must be magnitude, there must be unit. So in this case now, so if I was to write A now, if I was to write it like this A is having 10K. 10 is a quantity, is a magnitude. K is the unit. So this is the magnitude, this is the unit. So in terms of, okay, let me put it this way for you so that you will get it clear. So again, next time we have magnitude and we have unit. So let's say we have like this now. For A, the magnitude is 10, unit is K. For B, magnitude is 1, no unit, 0 unit. So for C, magnitude is 17. This one gives me meter. When I did it, I got meter. So for D, the magnitude is 25. Then unit is test meter. So you can see now, this one has no unit. This is not a quantity. So this is a quantity. So you can see now. So a physical quantity must have unit and magnitude. This is one is all. This one, A is quantity, C a quantity, D a quantity. This one not a quantity. Is it understood now?
Yes, sir.
Okay. So next.
A man of mass 72 kilograms, 75.2
No,
kg.
number what?
Okay, say number 3. Say you said that in your notes. Say you said that if values are close to each other, then they're accurate.
No. Which number one? Number what?
Number 3.
Number 3. Okay. For number 3. For number 3, a mass of this. A mass of this of 72.75 point this used to say what? Weighing scale to measure the mass 3 times. Okay. This is the actual value now. You are measuring 3 times. Okay. What statement describes the precision and accuracy? So precision means you find the range.
The what?
Precision means we are talking about the precision. We are going to find the range. If it's only one, but it's the one already two. We're supposed to find the range. Let's say where they have more than that. But let me just hold up. So accuracy means you find accuracy means you find the average and compare to this. So add up this, divide by 3. Accuracy means finding the average. Accuracy.
Then
That's how to
precision means percentage.
you have to find the average for you to determine it. So it means finding
Okay, let me find
the
that.
average. You find the average in order to determine it. You find the average in order to determine it.
Is 80.16666.
So add up all this, divide by 3.
Yes, it's 80.16666. 80.17 basically, yeah. Which is
That's
80.
80.17, 80.2 now. That's
Yeah,
80.2, I mean.
yes.
And it's too far. You can see now, it's too far to the actual value. That means not accurate. To be accurate means when you find the
No,
average, if it's close to the actual value, that means it is what accurate. But you can see now, look at the difference, 75.2, then 80, about 5 kg different. That was too far. So in this case, this is not accurate.
yes.
It is not accurate. No, but what's the difference between this and what's the difference in the readings?
It's 0.1.
It's 0.1. So it's 0.5. 0.1 is very small. That is precise because they are close. Precise means they are closer to each other. You can see now 8.1, 8.2, 8.2. They are closer. So that may bring precise. So if reading is closer, that means they are being precise. So this one is precise but not accurate. So precise, not accurate. The difference is very small. You can see now the distance between them, the difference between them is very small. That may bring precise,
Yes,
but it's
sir.
too far to actual value. So it should be D. Is it understood?
Yes, it's understood, sir.
Okay.
And then our number 7, sir.
7. Okay. Number 7. Now a single horizontal force. A single horizontal force is applied to a block X. We apply force to block X, which is in contact with a separate block Y at some distance. So the blocks remain in contact as they accelerate along the horizontal frictionless surface. Here is an equilibrium. X has greater mass than Y. So mass of X greater than mass of Y. So which one is correct? Okay. No, F is equal to NB. So we have this. Just okay. If we if they have the same acceleration, yeah, they should have the same acceleration. Acceleration should be where they have the same acceleration or different acceleration. If I want to look at M or A, let me say I want to look at the acceleration of A is equal to force. No, I'm coming at the force is that on Y is less than F. Okay, this F is starting on X. X will now exert, this one will now exert another force on Y. So what can we
Yes.
say? Yeah. So what can we say the force that the Y we
It's all,
experience?
it's
Oh,
greater than the one that X experiences.
no. This one is smaller mass now. This is the force. There is going to be the same, it's going to be this force. This force will make the two objects to accelerate together. So they will have the same acceleration. Yeah. They will have the same acceleration, but they will have different in this case now. When this one exert this, it will push the block and this also will move. Y also will move. But the mass, the force that Y we experience, it's going to be lesser than that of X. Why? Because we have because we have F is equal to MA. So definitely, if you look at it now, acceleration is going to be the same thing. In this case, they will accelerate to get A of X will be equal to A of Y. So take note of that. It will be the same thing. So in this case, F of X will be greater than F of Y. Why? Because of what? Because mass of X greater than mass of Y. So when they are the same thing. So this is what's going to happen. So if you use this idea now the acceleration of X is equal to force divided by the mass. It's not even of X. Okay. And this is still correct for only X. But I think we need to compare these two together. Let's see. Yeah, it's equal to the force divided by the mass of X, and which is correct. Fine. Or we can even no acceleration for X, fine. Or we need to find the two together, add the two masses together to learn to general acceleration. We're supposed to add the masses together to know what should be the combined acceleration for them. So this is not wrong. This is not correct. It's not only. So to calculate this force has to be the acceleration of X. It is the same as that of Y. That means we need to add the masses together for us to apply the force that is X exact on Y is equal to X is not equal to F. Why? Because mass of X, Y, is less than mass of X. So it's not equal to. So the force that X exert on Y, X force on Y, force experienced by Y, is less than F. Is going to, now, this is force on X is equal to F. That's what is happening. So force on Y will be less than F. Why? Because mass A is the same thing, but the mass of X is mass of Y is lesser. So that means force on X is going to be lesser. So the force on X is that less than the force Y. No. X is bigger. So C should be fine. Is it on that? Are we together? Is it understood?
No, sir.
Eh?
No, sir.
You said no.
So I said no.
You don't understand?
But you see
Wait.
that first part where you were like the force is greater and everything. I understand that part. Where you said the force of X is greater than the force of Y.
And that's it now. Okay, now if you understand this one, fine. If this one is understood,
Hey,
fine.
wait, I have a question. Why are you saying the acceleration is the same?
It's going to be the same now. Look at it because if you push, let's say you push this, you apply a force to push it like
Wait.
this.
Yes,
The two of
yes.
them will move
So
together. And
yes, sir.
uh
So
if
you
you
said the
push
force
on this,
of X is greater because it
yeah,
has
because the mass is great.
the mass of X is greater than mass of Y,
Yeah,
right?
yes. Yeah. Because if
Yes.
someone is
And
let's
now
say
you're
someone
saying that that X exists on less on Y is less than F. I don't understand that part.
and that's the force that X exert on Y is the
Mm.
force that the force with X exert on Y, Abby. So is the
Mm-hmm.
force that Y uses, is the force of Y. Is the force on Y, is the force on Y. Is the X that
The
acts
force
exert
that
it.
X exists on
Eh, wait,
oh the force that
it is
X
the
exists
X
on Y is the force
that
of
will
Y.
transfer force. It is X that this X will transfer force to this.
Yes.
And it cannot be the whole force. Why? Because the mass of this is less than this. So X will transfer part of its mass to Y. So that means the force that will go to Y is less
Okay.
than the original force of X. So it is X that will transfer, X will transfer, it will just see a part of its force. Okay, for instance now. Okay, let's do this.
Yes. So I think I got now. I
Okay. Now, if we do this, let's say the mass of X
So,
is 20,
and
mass
I
of
think
Y.
I got it. Can we move on
Uh,
to question 9?
okay. Question what? 9.
9. Yes.
So what's the against T? So you have an object falling. This one is an object falling. In a vacuum means there is no air, so no air resistance. So this one means no air resistance. This statement in a vacuum means there is no air, so no air
Wait,
resistance. So that
are you putting us because I can't see anything? Oh, now I can see. Okay, it's fine.
I think it should be your network. So because even your force is cracking at
No
my
air
end.
resistance.
The graph shows the difference of time t velocity against time. So what do you want to know? So this is v against time. Here now, v
Yes.
against time, meaning that the gradient, this means constant gradient.
Yes.
Constant
Gradient.
gradient, meaning that acceleration is constant. That's
Yes.
constant acceleration. Which graph using the same scale? Which graph using the same scale represent the object falling in air? When it's air now, A is not going to be constant. The gradient is not going to be constant. And as it's falling like this, the object is falling down. Oh, that's not
Mm-hmm.
even it. Velocity increases with air resistance and it will enter terminal velocity. So after terminal
Yes.
velocity, A becomes 0. So the answer is this is the graph B that represent that. B will
Mm-hmm.
represent. So it will be B. This is a graph of such. When you throw an object in air, less than air. So this is a graph when an object falling. Is there under the you see this is even under my notes. Is there this kind of graph? So B is the direct
Yes,
it
the
is the
answer
direct answer. Let me see. B
but the mic
either B or
says
no,
the
let's even see either B or C. Let me see something. I'm coming.
miking key says
I want to see something. That's what I'm looking at. Let me see. Please. Fun. Yeah, in the vacuum, the graph. So this acceleration is this one is this. Usually the same scale. Okay. The object falling in air. Okay. Oh wait. I think the other. Oh, okay. I think the problem with this is for this one, A decreases and becomes 0. That's this graph. Okay. Because the slope of this graph decreases P and becomes 0 when it becomes straight here. Yeah, it becomes 0. So, but I think represent in here. Well, maybe I think because the question did not tell us uh, it enters terminal velocity. So B means okay, B means decreases. The slope decreases to 0. C also decreases, but this one not to 0. This one decreases to 0. So this one does not decrease to 0, meaning that A acceleration of this one decreases and becomes 0 at terminal velocity. Okay, I think the problem is that we were not told from the question that there's a terminal velocity. It enter terminal velocity. So maybe that's why they say here. I think so. That's all. Because it should have been B here, but there's nothing telling us in the question that it doesn't enter terminal velocity. This one decreases and becomes 0. That means the enter terminal velocity. But if we are using this particular one, okay, see fine. We have the one we have here. A can never be 0. A is not 0 here. Here, graded A is going to be 0 at this point. C is the correct. Yeah, that's correct. That's correct. C is the correct answer. Yeah. From here, the gradient can never be 0 here based on this graph. So, and we are using this scale. We are using this one to justify this. So, yeah, this C is the correct. Yes, this is the correct answer. Yeah. Next one.
Next one, number 10.
One more.
Number 10. No, not that one. Number 10.
Number 10. Now, I noticed that you still have a lot. Wait, I want to change the format of this. We have a lot of things to do here because most of all this question now, it seems we have a lot to do. Well, maybe I will prepare against tomorrow, the next class. I want us to do this in a way that you will benefit from this class. Yeah, this is telling me that I still have a lot of them to do on each topic. Yeah, on each topic. A rock of mass, this is traveling a deep space at this velocity. This explode into two parts of equal mass. So which one is then stationary? Which one? Okay, one of which is then stationary. Okay, it explodes into two parts. Fine, of equal mass. Let's say we have it like this. It's going to be in opposite direction when something explodes, because that's the law. Before it explodes, momentum is zero. So when it comes to an explosion, before an object explodes, momentum is zero. And momentum must be conserved, meaning that a rock or mass deep this traveling with this and that. Okay, fine. So explode. So okay, I think this one is not at rest. Momentum of this one is that will give you 2mv. That momentum, mass times velocity, that momentum before. After now, this one now explodes into two of equal mass. So this is going to give me m, this is going to give me m, because it's 2m of equal mass. One of it is then stationary. I don't know yet. So I can say this m1, this 2. I have the same, this is, no, let me put it this way. This is object 1, this is object 2, fine. One of it is stationary, meaning that it means that momentum of that one is zero. So let me assume this is stationary one. Stationary, meaning that momentum is zero. To be zero. That's what it means, being stationary. Momentum will be zero. Now, velocity of this one we don't know. The velocity of this one, let me call it v. Velocity of this one, let's call it v2. So we know this one is zero. Velocity of this one v1 f. This is v1 rather. Object 1, object 2. That is zero. So what are we looking for? What is the kinetic energy of the moving parts after? Okay, kinetic energy after the explosion of the moving parts. Okay, the moving parts, Abby. So this one that's moving, this one is stationary. So let's go and look at velocity of this one first. And the law says momentum before must go to momentum after. This momentum before 2mv. Momentum after, that will give me m of this, then v1 plus momentum. This one is zero. So let me look for v. So meaning my v1 supposed to give me 2mv over m. So my v1 supposed to give me what? 2v. That's my v1. So let's calculate kinetic energy. That's mv squared over 2. M is mass. V is 2v. 2v squared over 2. Do the mathematics now. If you do this mathematics, that will give me 4 mv squared over 2. That will give me 2 mv squared. 2 mv squared. So I think that's supposed to be. So this should be the correct answer. D. This is the correct answer. Simple method that I did. You know what I did here? So this is the momentum, mass time velocity. This is the mass time velocity V. The question says the split into two equal parts. That means mass is 2m divided by 2. That's what mm. Now one is stationary, one is moving. So I call the velocity of the moving part V. Use the law of momentum here. Using law of momentum here. Look for V, then calculate velocity. So I think that should be fine. You might need to write it down.
Yes, I'm taking a screenshot.
Next one.
So the next one is okay. Let's see. Number 11. Sir. Okay, let me
Number
tell you
11.
what I. Yes, sir. Okay, so let me tell you what I did. Then you tell me where I went wrong. So, okay, read the question first.
So so where is the problem with it?
There. I said okay, I resolved it, right? And then I got the horizontal component as 16 sine 30. Then I said times the 50, say 50 times 10 to the power negative 2, right? And then the other
You
one
don't
is
no, you don't need the horizontal component.
5.
You don't hold on. You don't need the horizontal component. Horizontal component is going to be
Am
the
I not supposed to find a force that is
no.
perpendicular to the distance?
If you do
The
horizontal
vertical,
component,
sorry. I meant to say vertical. Sorry.
okay,
Yes.
okay.
I got the vertical component. I got 16 sine
So
30, right? Then I said times times the 50 times
it
10
should
to the
give
power
you
negative
16.
2. Then I said
You don't need negative cos 30. That's all. Just
say
resolve sorry, sine 30 rather. So just resolve to vertical, that will be sine
is
30.
it not sine?
Sine, and that will be 8.
Then is it? Yes, it's 8.
Mm-hmm.
So 8
Take
times
moment.
50 times 10 to the.
So take moment. This one will move like this. This also will move like this. Come here. So this one is what? Anti. Why this one is clockwise? So we have to calculate clockwise separate. Calculate this one separate. That will give you 8. Moment of this will give you 8 times what is distance? 50. Moment of this one will give you 5 times 50 as well. So what does it give? Subtract the 2. That will give you the resultant moment. Yeah. Multiply this.
So that's what I did, but I didn't get the answer. Because the
You're
other
supposed
one I got 50
this
times
to
10
first.
to the power negative 5. I got 2.5, and the other side I got 4. 4 minus 2.5. Oh. Okay. No, sir, it's fine. It's fine. Okay, next.
Eh? You convert it
No,
to
sir, it's
meter.
fine. Yes, sir. I managed to get it.
Okay. Which one?
Yes, sir. The number 14.
40.
14, 1 4.
Okay. Ah, what is the unit for density, please? Density equals kilogram per meter cube.
So
So which one will
density
give
is
you
mass
that?
over volume.
Eh? This be unit now. So which one will give you this? Maybe try this and see. What's the Newton?
Wait, okay, A is wrong. A is just wrong because uh
This times meter.
kg meters.
Now come on. This one Newton means this. Then this one is power minus 3.
Is
So what
wrong.
are you going to give? Okay, it's wrong because of this. Fine.
Yeah.
A is wrong. B, wait, G means what? What do they mean by G? Is it gram? I think this gram.
Grams.
Okay, gram per millimeter. Okay. We can have gram per centimeter.
Then
We can have per centimeter cube. We can have this one. This one. Let me see this one. Microgram per centimeter per meter. This micro. Micro means -6 here. Microgram. Okay, fine. This one is millimeter. I want to convert this to meter. Let me convert this one to meter and see what happens. So I want to centimeter possible because it's going to gram per cent. I can have gram per centimeter cube. Either way is correct for this unit. But let's try to see how we can if this one is not possible, I don't think so. But let's try to convert this one and see. So I want to convert centimeter, meter, millimeter cube to centimeter. How many centimeter making millimeter?
one
How many
10.
10 what?
You said millimeter.
Uh-huh.
It's
1
10.
millimeter equal to what? 10
1
centimeter.
millimeter. Yes.
Okay,
No.
fine. So
No.
hmm?
No. 1 centimeter. 1 centimeter is equals to 10 millimeters.
Okay, 1 centimeter equal to 10
Is
10
equals
what?
to 10
Millimeter.
millimeters. Yes. Millimeter.
Uh,
Yes.
and let me confirm that 1 centimeter to meter. That's what? Power minus what? 2 meter. Where this one to
Yes.
meter?
Yes.
Okay, and yeah, I think okay, it's correct because this one means 10 power 10 2. Okay,
Mhm.
that's correct. That's correct. So all this 1 centimeter to millimeter. Okay, fine. You you have 1 centimeter to 10 millimeter. 10 millimeter. So now I want to get power 3. I want to get minus 3. Both side by minus 3. That is simple mathematics. So this is going to give you. So this is going to give you what now? 1 centimeter. This is going to give you what? 10 minus 3 millimeter minus 3. So that's all. Now, with this knowledge now, so I can say millimeter now to this. So I can now have from here. It is just, all these are normal, just simple mathematics that we can just try to work around with. So with that,
That's
so with this, I can say millimeter is equal to centimeter divided by minus 3. Yeah. So I can do it as well. 3, I can now
3.
do 3 centimeter cube. Yeah. So I do it, I divide both sides by power minus 10 minus 3. So I can conclude that 1 millimeter, now that is millimeter cube, equivalent to 3 centimeter cube. So we have gotten this. Yeah, let's now see. This is what we have now. Let's now operate this one. We have that's micro rather. So that's microgram, millimeter, 3. Micro means power minus 10. Let's leave gram. Yeah, instead of this, you can see now I'm writing this. You can see the old this. You can see now equivalent to what? This. Equivalent to this. Are we together? So I'm writing 3 centimeter this. So yeah, if you do that this time this, that will give you. So that will give you. I don't need the value, but let me just put the value there. That will give you minus 3. Anyway, I don't need the value. I just need this and this. So that's gram per centimeter cube. And that's what I need. You are going to have minus 3 here. This is a magnitude. It does not matter. What matters is the unit. So you can see now gram per centimeter cube. So this is the answer.
Okay. Say. Ish, but I still don't understand. So can you work it? Okay, can you explain that working again?
This is very simple here. I just try to get the units from here to
Once
here. This one is so this to this.
-3. Yes.
I need power
Then
minus 3. So I need to put power minus 3. Just put power minus 3 here. So that led to this one. So from here, this is the one. I don't need to replace this one. So this
then
one's got
from there,
15.
where did you go? Hmm.
This one does not really mean this is micro, this is just microgram. We don't need you need to replace this one millimeter. Is equivalent to what? Centimeter cube. So this is equivalent to this. Just put it there. See what I think from here. This is this. So I don't need to more. This is a magnitude. This time that will give me minus 3. I don't really need the value here. But I need this. That's the unit. I only replace this. I only replace this one with this. I replace this one. I replace this one with this one. That's all. Because
Okay.
you call the unit equivalent. Are you are you okay with it now?
Okay, I'll go over it. So if I don't understand, I'll ask again.
Okay.
Yes. Then let's move on to question 21.
21. That should be waves.
That one.
Waves
Isn't the wavelength is 3,
20.
right?
Is it this one? 21.
Yes. So that wavelength is 3, right? 3 centimeters.
So after today, but because for you to be successful, I'm going to drag you back to the real format. All this, I understand that we need to do some certain thing because all these are the thing this thing is under waves generally beginning. I remember the first day. No, yes. You said we started from superposition. That's what you wanted us to
Yes.
start. These are the beginning of waves. These are the beginning of waves. All this idea. There's something that's called is there. Because time
And
base, you're
then,
looking for estimate of frequency.
yes,
So
the time base
you have to
is
go and calculate
2.
the period time
8 times
base.
10 to the power negative 3.
Time
Yeah,
base
that's right.
times is here in my note. So the period will give you time base. multiplied by number of divisions in a cycle. The
What?
complete
Okay.
cycle from here to here, that's a complete cycle. From here back to this place. But we cannot really calculate how many O's here. You can see now 1, 2, 3. No. So it's very difficult to calculate here. The cycle is from here to here or from here to here, either this and this. But it's not starting, we cannot say this is one because it's not starting from here. So the ideal is
Okay.
you have to
10,
calculate
20.
everything
So
together.
say I multiply the 10 base.
Let's calculate the number of
Okay, so
cycles
I
here first.
multiply the 10 base. Oh, yes. I didn't say times 3,
Just
right?
listen.
And then, oh, okay. No,
Not
it's
three.
fine.
It's not 3. It's not 3. 1, 2 is not 3. It's less than 3. Because 1, 2 is less than 3. This is 3. This is the place. It's less than 3. So you can't get 3. You can only
Okay,
guess. It's not
2.8.
possible. But you are trying to guess. But it's possible for us, so we can get it
2.9.
possible. Just listen first. You
2.9.
can get it. I'm not following that method of guessing. So how many cycle will I see here? This is 1. This is from here is
2
1. This is 2.
and
This is 3.
3.
And that will give me
Oh,
3,
and
like
and
3.
that's
This is 3. Yeah, that's 3.5 now, like 3.5, around 3.5 something. Because from here to
2,
here to this
3.
one. But yeah, if I say this is from here to here, that's so this is 1. This is 2. This is 3. This place is going to give me around 3.5 or more than 3, maybe 3.6. I can say maybe there's something like 3.6 cycle. It's more than 3.5 because this place is extend beyond 3 point, 3.5, 3.5 something, 3.5 or 3.6. Okay, let me just say 3 point, let me approximate. That's why I say it's an estimate. Which one is very close? So I have 3.5, 3.5. Let me say 3.58. I can use 3.5, but let me just 3.5 because this is more than from here to here. It's more than a side. It's more than like dividing on 3.58 or 3.6. I can say 3.6. If I use 3.58, so how many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can see 10, or I can have 3.58 or 6, 35 a cycle equal to 10 O's. Is equal to 10 O's. 10. So 10 O's. So one cycle now in a cycle equivalent to what? What will equivalent to? Let me call it X. I don't know. So as you cross multiply here, that's the idea. So we are going to have 3.5. Okay, I say I want to take 858. X is equal to 10. So X will give me 10 over 3.58 O's. So in this case, so let me see first. So time base is given as 5 milli. This is in milliseconds. So 5 milli, that means 1 milli means minus 3 times number of different second in the or in a division. So I try to get 3.58. Multiply this thing for me. Let me see what happens. So when you multiply, you now find frequency as 1 over t. This is the period. Yeah, press calculator. Let me see.
I got 1.79 times 10 to the power negative 3.
Okay.
Then
Yeah, 1 over this. Yeah, find 1 over t. Yeah, find it now. Find this formula 1 over period frequency.
500 and 558.
Are you sure?
What? No. So let me calculate again. I don't know why I'm getting
I said this
10.
particular one is correct. This and this.
Yes. Divided by 10.
Not over this.
A 1 divided by equal A. Ah, 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 ah. 8.
You also follow the formula, the idea that here is 1, 2, it's not 3, maybe 2.8. It's also be very close. We can guess maybe 2.8 division. You can just have 5 power 3 times 2.8. I can just have this straight. Yeah, it should be very close.
Oh,
I'm waiting for you to get calculator right.
yes.
So I can also make use of this. Yeah, it will be very close to. I can say this 0.8, yes, 0.8 like that, or 0.75, 0.8 like that. I can just say 5 exponential minus 3 times 2.8 as the t. So I will now calculate the period,
3.3
frequency as 5
is 10
times 2.8. Press calculator, let me see.
5 times 10. And then 1 divided by alpha. Okay, I'm getting 71.6 now.
7.9 is an approximate, so it should be around this value. That said,
Yes.
an estimate might not be exact. You might not get exact 71, but it should be that this one is close to 7. That's correct. So you can get anything as an estimate. So 7B is the correct answer.
Yes.
Yes. Next one.
Okay, so the next question is question 24.
Twenty-four.
Say, isn't that saying that zero resultant
20,
amplitude, say
20 what? 20 what?
20, 24?
24. Okay.
Zero
So
resultant, so it's destructive, right?
zero resultant, destructive.
Yes. So
Well,
now
two
say,
points from different sources meet at a point which condition must be satisfied for there to be zero resultant amplitudes. Okay, that means they must be equal. They must have equal amplitude and they must be opposite for them to have zero resultant now. So they must be equal, just like A minus A equal to zero. So they must be equal in magnitude and opposite. So let's say the two waves must be emitted from the source with the same intensity. Same intensity means same amplitude. Okay. The two waves must be in phase with each other. They must be out of phase. This is not even correct. First, must be traveling opposite. Fine. The two waves must have same amplitude at the same point. They must have the same amplitude. They must have the same amplitude. This one means they must be traveling opposite. If they are traveling opposite and they don't have same amplitude, they can never be zero. This was not correct. Yeah. Now they must have the emitted from the source with same intensity. Amplitude is the amplitude we are talking about now. Same amplitude. Two waves must have same amplitude at that point. Yeah, not from the source. At the point they are considering, they will have the same amplitude. So, although it's not really complete, they must have the same amplitude and they must be opposite. So these two supposed to be together as one.
yes.
That's the best way. It's supposed to be together
Say,
as
so
one.
you're
That is
saying C is wrong. C is wrong because even if they didn't have the same amplitude and were traveling in opposite directions, they wouldn't cancel out,
it
right?
cannot be zero. It could be zero. So
Yes, it
even
can
they
be
have
zero.
an opposite. They were not whether having the same amplitude. They didn't tell us, so it's not possible. So the two of them are supposed to be together in the normal setting. So as long as
Yes.
you cannot sit together, so the best one is D.
Yes.
So they're supposed to be together. That's the best thing.
The number wait, where is this one? Okay, so let's do let me see how much time is left. Okay.
Number what?
Inefficient. Number 28.
28. This one. So still wait. Now I won't take okay. Light of a single wavelength is then normally on a diffraction grating. The resulting diffraction pattern is displayed on the screen, which change makes the first order of intensity maximum further apart from each other. Okay, you have it like this. So let's say this is central. You want to make it further apart. You want to increase the angle between them. That's not further apart. So this is this. This is the first maximum. So you want to making it further apart means that this angle now, yeah, that's the angle between them. So what changed? And this is the formula is this sine theta n lambda. This is the formula. So placing the screen closer to the diffraction grating. So let me find theta. I want to further find me. I'm to increase the theta. Sine theta will give me n lambda over d. This is the spacing. So in this case, diffraction grating, okay, the diffraction grating, this part coming using the diffraction grating with less spacing. So we want to get further apart, mean theta must increase. This is spacing. So you can now see now, look at theta. Now theta very last one, 1 over d. So inverse.
Yes.
This is the correct answer. So if it's less, then sin theta will increase because you want to increase. This is the answer.
Okay. And let's use this. Let's see. Okay. Number say number 34.
34. Electricity.
Yes. Yes.
Okay, this one. I'm going to do that this as a one. Now, tomorrow, this is what I'm going to do. You are starting the exam when? October when?
On the
You have this subject. October when?
let me check. You mean the first paper?
You have this
Um,
paper, either paper two, or paper
on
one.
the 16th of paper 2, the 16th of October. I'm left with 56 days.
So that means paper one will be around November.
Yes, paper 1 is on the 13th of November.
Okay. So I'm coming 16th. This is August, like September, October, like 2 months now. We want to rush through all this, the topic. This electricity now we're going to do it as a topic and solve question on it. The same thing. So we are going to do it as a topic, but no problem. Let's look at it today. Instead of
So tomorrow, say we're going to do all those worksheets that you sent me.
all the what?
the worksheets, like those questions that you send me. Is that what you want me to do?
And that's what I want us to be doing. I'll explain the topic, the concept on it. Then we will now solve all those. There are many questions on that topic. We will solve. That's the way for you to master it. So I don't want us to be grappling from one topic to another, from one topic to another. So that's the way you will understand it better. That's the way you get it
Yes,
better.
say
So
me. Okay.
say you have all the note with you. I will just pick which one we're starting with. You have all. I've sent
Say,
them.
tomorrow, let's start with deformation in solid. Say tomorrow.
And just start and make sure you finish the question. And before you can't even
Say,
just
you
the
didn't
formation
send
of
me questions on that topic.
you can't start the formation of solid because it's connected to other topics. There's a way things supposed to be done. It's like it's connected to other topics. Like what kind of power is there and forces are there.
So
You
we
need
should
to
start with
understand.
chapter one.
So just quickly run through this. That's the best way. So run through
We
like
should
all
start.
this. Yeah, but that will be the best. Just run through some certain things that will get idea. The day this and that.
Okay.
Please.
Let's start
So
with chapter one.
that's of benefits. It
Yes.
will really help you that way. Moving from one point to another, you won't really get the concept. The electromotive force of internal resistance is connected in variable. Okay. The resistance of the variable resistor is gradually increasing. So variable, this is the one now. This is a variable resistor. We are increasing this one. This resistance from R to 3R. So what happened to the voltage? Now, this was a scenario. This is the EMF, internal resistance. So let me follow. This EMF here, you are distributing into three. These are the understanding you need to have had about this concept, the topic. So I won't be accepting this method again from tomorrow. I will do it the way I know it's supposed to be done and going to be to your best. So you see it into this one will have its own PD. Then this one has its own PD. Now the EMF here, EMF will be divided into two. One comes here, another one comes here. So meaning that EMF will go to PD across this one plus PD across the bigger one. This is bigger one across this V here. So, or let me say this PD, this one is called small letter V, internal resistance. This is PD. This one is small letter V. So this one is capital V. That's going to happen. Now, if you are increasing the resistance here, that means the PD of this one will increase. Let's look at it. Look at it this way. Let's assume that E is. Don't let me go far like that. Let's say I have 20 as E. E is
Yeah.
12. Remember, 2 of them must equal to 12. Let's now say small letter V here is 4. So then the capital one is going to give me 8.
Yes.
Now, as I'm increasing this resistor, PD, this one will increase. If you increase resistor, when it's R, if you increase the resistor, this one will increase. Let's now say this one increases from 8 to, let's say increase from 8 to 11. What should be this one? This one
Yes.
will be equal to, this one will decrease to what? I'm
One.
asking because 2 of them must equal to 12. If this one
To
increases
one.
to 11,
To one. To
to
one.
1, to 1, you can see now. 2 of them must equal to 12. You can see now. So looking at if you have that idea now, so you're able to that idea we're able to solve this. Resistance of this one increase gradually, meaning that means the PD across this one will increase, the PD across internal resistance will decrease. That's what it means. So which graph show the variation of the potential different across internal resistance? Can you see now across internal resistance with PD, okay, across the variable, okay. You can see now the PD, okay, they are saying now total PD, this one is 1, EMF is 1 now. That what it means, 1E, this EMF is 1. Now if this one increases, so let's now see internal, okay, this okay, the one, this internal resistance in small letter R, this is a capital R now. So internal resistance decreases from here to here, so decreases. This also increases. That's correct. V increases. This is correct. This is looks correct now. Look, A looks correct too. But let's go and see other. So if you go and let's go and see other and see what happens. So A looks correct now. Why? Because we know that V small letter V will decrease. You can see this one is decreasing from 0.5 to something else to something here. So A looks correct. So here you can decrease it. And this one increase from 0.5 to here, which is justifiable because I can say capital V increases, small v decreases. Are we together?
Yes, sir.
Okay. A is even
Good.
fine now, but let me see
Yeah, but
other.
I don't
If you look
understand. I don't understand that graph.
this graph, look graph is saying from 0.5 moving at this point. What's the value of this here? It's less than 0.5. That means decreases.
Mm, mm, mm.
That means decreases. Do you agree? At this point, what's the
So
value here?
they are saying it decreased from 0.5 to that.
So something it decreases. Small letter
Oh,
v is meant to
so that is
decrease.
small letter v decreases.
It's meant to decrease. That's what we did
Yes,
there. You can see now.
yes.
Abi? You
I
can see
understand that part. Trying
What
to
of this
understand the
one?
graphs. They go there.
Capital
What
V.
about the capital V,
Capital
sir?
V is meant to increase. Can't you see the value here? From 0.5 to something. Is it not increase? From this is
Oh,
where it is before
it
0.5
has
to
0.5.
this. To something. Does it not increase?
Oh, oh, that's true. That's true, sir.
This will be fine. If you look at this one too now, this one does not follow. Look at this one decreases. Fine. This is correct. It decreases. V small letter V decreases. But what of E? Capital V. Does it increase? You can see now. You are 0.5, you now move to something else. That means this one, both of them decreases. It's wrong. So you can look
Yes.
at this one. This one means V increases. Look at this one. Small letter V increase. Does it increase? No, it decreases. So it's not correct. It's not correct. So this. That's why I say if you explain the topic as a whole, you will get all these things. Not see simple analogy I explain here. So that's what is going to be on the next thing. So which other one here? So we call it. We'll do it like this for today. So from tomorrow we are going to start a proper way. Let's do